Hey guys, hoping all is well with everyone. So in this video series, I'm going to be introducing to you guys some fun mathematical life hack videos. Essentially what it's going to be is just a compilation of fun videos with some fun tips and tricks that aid and facilitate you in quick mental calculation of mathematical based properties and other operations. I understand fully that more than likely you will not be asked to mentally calculate the cubic root of a 5 or 6 digit number, but after watching this video, you will be able to confidently do so within a matter of 5 to 10 seconds. And if you guys are new to my channel, I'd like to formally welcome you. If you guys have any requests for any mathematical support related requests or videos, I'd be more than happy to do them for you. I'm also a fan of doing a lot of fun science demos and experiments, anywhere from biology, physics, chemistry, middle school science, as well as some readings of fun read-along stories. So again, welcome, and without further ado, let's go ahead and jump into the video with our first topic of mentally calculating cubic roots. So when you first probably clicked on this video, as well as looking at that this is the first video in the series, you're probably asking yourself, why in the world is he choosing cubic roots versus at least square roots? And the answer to that, ironically, is that mentally calculating cubic roots is a little easier than square roots, which is a little unexpected, but I'm going to be explaining to you why that is after our first example. But what we're going to go ahead and do is look at our first example. So let's say we were asked to mentally calculate the cubic root of 24,389. Now, one of the things that you want to do before jumping into this head first in terms of this mathematical trick is being very comfortable with your perfect cube values of bases 1 to 9. The reason for that is the perfect cube values that are associated with this are going to help you break down the approach to calculating these 5 and 6 digit number cubic roots. But what's even more pivotal are their individual digits of the perfect cube values, which we'll be looking at more importantly as well. But after being very comfortable, so let's go ahead and start by just doing a quick refresher of the perfect cubes of bases 1 to 9. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is equal to 729. Now, those dashes that are in those located spots over by these numbers, they are important, but I'll explain, you'll see why in just a couple moments. But to start things off, what you're going to do is you're going to hone in on the last 3 digits of the number itself. And then more specifically, you want to zone in more on the final digit. What your first task to do is to identify the perfect cube value whose last digit is the same as the last digit of the number that you're trying to find the cubic root of in question. So we need to find a perfect cube value that ends in 9. The only one that ends in 9 as a perfect cube value is 729. One of the reasons that calculating perfect cubic roots is easier than square roots is because all of the numbers or all of the final digits of the perfect cube values are different. So what we do is we'll hone in on 729 since its last digit is the same as the cubic root in question, and we're going to choose the base as our first digit of the assemblage of our final answer. So it's going to be so we're going to go ahead and put a 9 here. This 9, as it is the base that corresponds to the perfect cube value, whose last digit is the same as the cubic root in question. So now we've accounted for the last 3 digits. Now we're going to hone in on the 24 here. Now our task is to look at this value here and find the perfect cube values that fall directly below and above this value here. So I'm going to look at 24 and look at the perfect cube values that are directly below and above. So that falls between 2 cubed, which is 8, and 3 cubed, which is 27. I can't choose the one directly above it because that exceeds the value. So what I'm going to do is when I get to that pinpoint is I'm going to choose the perfect cube value that is directly below, and then the digit that I'm going to put in as my final answer digit is going to be the base. So that's going to be 2. So just a quick recap there. I looked at the value here that is remaining of what was not the three-digit number here, and then I go to the perfect cube values that fall directly below and above, and I'm going to select the perfect cube value that is below, and then the digit that I'm choosing is the base that corresponds to that value that I chose. Okay, so our final answer to the cubic root of 24,389 is indeed 29. Okay. Let's go ahead and look at our second example, but before we do, I want to go ahead and show you a little bit more justifiable evidence of the square root aspect of things and why it's a little bit more tricky and contains an additional step. So let's go ahead and approach it the same way that I would do this way. So let's go ahead and look at our perfect squares from bases 1 to 9. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and here's where you'll start seeing a little bit of a pattern. 6 squared is 36, 7 squared is 49, 8 squared is 64, and 9 squared is 81. So what you'll notice about the square root approach of the perfect squares of bases 1 to 9 is that their last digits are not all uniquely different. In fact, they repeat each other quite often. They're almost mathematically symmetrical around the middle number being 5. So your lowest and your highest perfect squares have the same last digit, and then it kind of they kind of match themselves. So kind of here, and then 2 squared and 8 squared and so on. But what you'll notice is that they repeat. So what you have to do when you would approach this type of problem with the square roots is you'd have to discern which base you need to correspond and account for at that point that they are the same. So it's an additional step, and I'll be going over a video on this as well, but just to show you kind of the reasoning of why cubic roots are a little easier, being all the last digits are uniquely different. So let's go ahead and look at our second example here. Let's say we were asked to find the cubic root of 132,651. Now, remember, our first goal here is to hone in on the last 3 digits, and then more specifically zone in on that last digit, this one being 1. So what I'm going to do is I'm going to look for the perfect cube value whose last digit also is 1. So the only one that's last digit ends in 1 is 1 cubed, which is 1. So I don't want to repeat 1 too many times, but this value, even though it's only 1 digit, ends in 1, which corresponds to the same ending digit of this number. So I'm going to choose the base that corresponds to the perfect cube value that meets that criteria. So it's going to be 1 as our first digit as part of our final answer. Now the only difference between this question and the last one is that this is now 3 digits, whereas the last one was 4. And that's okay. Or the last one was 2. That's okay. It's the same direct approach. Basically what we're going to do is look at the perfect cube values that fall directly below and above 132. So that's going to go and be between 125 and 216. So I would go directly below that to 125 because 6 cubed exceeds the value of 132. So I'm going to go to 125 because it does not exceed 132, and then choose the base that corresponds to the value that meets this criteria of not exceeding but is closest as a perfect cube to this value. That's going to be 5. And then that is our answer. So our final answer to the cubic root of 132,651 is indeed 51. Okay? Alright, let's go ahead and look at one more, but I want to give you guys the opportunity to go ahead and pause the video to allow yourself an opportunity to approach this and try it out for yourselves. So I'm going to go ahead and write it down. So the question, the cubic root in question here is the cubic root of 405,224. Okay, I want to give you guys an opportunity to try that, so go ahead and pause the video for a second if you would like, and give it a shot, and we'll look at the answer in just a second. Alright guys, welcome back. So right before we paused the video, we went ahead and looked at the cubic root of 405,224. So again, our first step is to go ahead and zone in on these last 3 digits, more specifically 4 as the very last digit. Now I need to find a perfect cube value that corresponds to the last digit is the same as the one in question here. So I need to find a perfect cube value that ends in 4. And we see that the only one that is a contender is 64. So I choose the base that corresponds to that perfect cube value, which is 4. And that's going to be the first digit toward our answer. Now that I have accounted for the 3 digits here, all that's remaining is the 3 digits here. So I look at the perfect cube values that are directly falling below and above 405. The 2 perfect cubes that are going to correspond to that are 343 and 512. But remember, I can't exceed the value itself, so I can't choose the one directly above it, and that means that I'm going to choose the one directly below it because it meets the criteria of being the closest without going over. And then I choose the base that corresponds to that perfect cube value as my next part of my answer and final part of my answer. So the final answer to the cubic root of 405,224 is 74. Now again, I hope you guys enjoyed this video. If you guys have any requests or any questions about this approach, again, these were more for 5 and 6 digit numbers. I'm going to be doing more videos that kind of go more specifically into other situations. But I hope you guys enjoyed this first video of this series. I look forward to seeing you guys in more videos as we go forward. But as always, guys, thank you so much for watching and supporting my channel. Please take good care of yourselves and be safe. Bye.